Welcome to the Infection Prevention Strategy Tips Masterclass, the emerging threat of biofilms in hospital drains and other surfaces, new approaches to impact contamination and HAIs. We have a disclaimer. Please refer to your local government and regional health authorities for any specific instructions on all topics mentioned in this webinar. The learning objectives here are stated on the screen. This talk we will not be offering C credits. However, we do have specific learning objectives for the program. My name is Dan Mueller. I'll be the moderator and the first speaker today. I've been involved in the infection prevention space for over 20 years, bringing innovative technologies to address and impact HAIs. Our next speaker is John LaRochelle. John is the president of Lighthouse Environmental Infection Prevention. He's an international speaker, recognized thought leader, and subject matter expert in environmental infection prevention. He serves as a senior advisory board member for GBAC as well as TIPS. His 40 years in environmental infection prevention has positioned John as one of the top experts in the field. The webinar series is hosted by TIPS. TIPS is a nonprofit that exists to advance innovative ideas and processes that make a difference in global health. TIPS extends to over 30 countries and is the key strategic partner for many notable organizations, initiatives, and events. In the past years, TIPS has contributed millions in scientific network. Our motto is join, contribute, make a difference. There's 4 programs within TIPS. These are offered as free services to clinicians and any interested party. There's the Science to Market, which helps with new technology. There's a TIPS journal, which has a peer-reviewed journal. There's deep dive interviews, and then the last one is a masterclass, which is what you're involved in today. If you have any questions, we're going to do a Q&A at the end. We expect a good number of questions. We've got quite a number of people on the line. We've talking about some interesting and a lot of topics that you're seeing a lot in the peer-reviewed publications. So go ahead and just type your questions in the chat. In case we don't get to the questions, we will have those questions published at the end. And also, we will be recording the webinar. In this webinar, you'll get a follow-up email, and you can view the webinar or you can forward it to interested party, and that'll all be hosted on the TIPS website. Let's jump into biofilms. I'm going to get us going here talking about biofilms, and then John's going to dig more into some specific solutions. Over 60% of human infections come from biofilm formation. A lot of these are specific in the wound care sector. They can act as a reservoir of pathogens at hospitals. Really, the big thing that they do is they protect these pathogens against any sorts of environmental chemicals or other actions to try to kill them. Typically you think of biofilm a lot in water. You look at catheters, trach tubes. Really, what we're going to be focusing today is on how biofilms help protect pathogens in different surfaces, specifically in drains. And then we're also going to dig into toilets, how those biofilms are helping protect those pathogens. Why do they form biofilms? I know a lot of you are infection prevention experts, so we're not going to go super deep, but the bottom line is it's really about protection. It forms this, I was thinking of it like an armor. It's like an armor plate around these pathogens. And it also, we'll get into it, actually, the pathogens actually can adapt. They change. They become less susceptible to, for example, certain biocides such as bleach. Bleach would typically kill a pathogen, but when it lives in a biofilm, it becomes much more or much less susceptible to that biocide. The other thing that's really interesting that's becoming more and more, there's kind of early in the research is in terms of interactions within these organisms. So within the biofilm, you've got communication going back and forth. The other reason they form biofilms is it gives them access to nutrients. You know, without the biofilm, they can be dried out. This access to nutrients lets them live. And then the other areas, they're always on the defense against the white blood cells and neutrophils, and then also the amoebas are always going after them. So all those different things. You ask why they're joining these biofilm group. That's the reason why. Just basics on, you've probably all seen this slide before in terms of, you know, the attachment. It starts reversible, then it goes irreversible. In terms of speed of the growth, and John will get into how quickly these biofilms are growing, it's quite remarkable. I mean, the biggest challenge I think with biofilms is that you can't see them. And up to this point, there are some technologies that will visualize a biofilm. There's some new technology out there that's using different light frequencies to show the biofilm, but they're not really widely used, and they're kind of in the early stages of development. You don't see them. They grow. It's really once you get to a certain point where they become strong enough that they'll really exhibit these defense properties, and that's really in the 10 to 5 to 10 to the 6 CFU. The other point is not really going to dig in today, but you hear about certain products that can impact biofilm, certain chemicals. The problem is if you interface or you kill part of a biofilm, it'll typically grow back even stronger. So it's really important to try to completely eliminate or completely kill or just not allow that biofilm to form. Easier said than done when you're looking at a wet environment, a sink drain, dark, lots of nutrients going in, and that's what, you know, the challenge. I've heard drains are an unsolvable problem. I've heard infection preventionists say this is just a problem we cannot solve. I think that's I appreciate the sentiment, but I think we can definitely make big strides and make improvement, especially for immune compromised patients. Really, one of the big challenges with biofilm is biofilms can produce up to 1,000-fold antibiotic resistance to a bacteria in a biofilm versus living in a planktonic or free-floating state. So meaning you have a bacteria, and once it gets in a biofilm, it can be 1,000 times increase or 1,000-fold increase in antibiotic resistance. So it really becomes a different pathogen. It may have the same name, but there was, in this specific study, they had a staph epi in a biofilm. All of them were susceptible to vancomycin, which is a common antibiotic. So the antibiotic worked 100% of the time. But when that staph epidermis dropped into a biofilm or was living in a biofilm, over 75% of them were resistant to the same antibiotic. So on top of the lack of antibiotics on the market, the ones that are being used, this is really you read a lot about antimicrobial resistance, and we could talk for hours on that. We're not going into the detail there, but it just shows how biofilms help contribute to that antibiotic resistance. This is really a new area. We probably know less than we'll learn more than we know now, in the next couple of years, but there's a lot of communication going on within the biofilm, when to become, when to eat, when to flee, when to multiply. There's a term viable, but not detectable, but it's where they become dormant, so they're not detectable, but they're still there. So it gets really smart. It's a community within that biofilm. The other really scary piece is that their ability to transfer DNA. So one pathogen can transfer the DNA into another, which is, again, getting really smart and getting very, very difficult. And again, we're still in the early days of this information. So I think this kind of sums up, the pathogen goes to the shrink, and I can't get with the flow anymore. I've been thinking about joining a biofilm. So you can see why, if you're one of these pathogens, and typically we talk about bacteria, but there are viruses and also other pathogens living and thriving in a biofilm. Jumping into sinks, I'm going to just go into a little bit of background. John will dig more into some of the solutions and other specifics, but essentially there's three methods or ways that the biofilm contaminates actual sinks, and one is direct growth. So you'll literally see the pathogens in the sink. I've been involved in a couple situations where a hospital will, start to address either through chemical remediation in the sink, and the first thing they'll say is there's this black stuff coming out of the either up the sink or out the air, the overflow valve. I've had this conversation, I think John and I've had it a couple times, where we get a picture and they say there's this black stuff coming out. What is it? And I mean, you don't really know what it is till you culture it, but it's pretty evident that that's your biofilm. Okay, what's in the biofilm is another question you need to go into, but so that's the obvious one. You see that. The next one is the splash droplet. So that's the droplets around the sink. So you'll see those as well. And those would be, you wouldn't really know whether that's a problem or not. And then the last one are the aerosols. Those are deadly. They can be inhaled. They can, obviously microparticles, very deadly. Those ones you don't see and go into more detail in terms of when the water comes down into the drain and you have the splash effect, and you can have aerosols that are traveling, halfway across the ICU by the patient, contaminate surfaces in the surrounding area. So those are really kind of the three general areas in terms of how these biofilms are contaminating the sink. We could spend probably 3 hours talking about all the papers linking drains contamination to infection. I mean, at APEC the year prior, there were three papers. There seems to be a kind of a general trend. I mean, they're gram-negative, so you see a lot of Pseudomonas. You see more Phenotrophomonas. You culture, you link the DNA from the drain, the bacteria in the drain, to the actual patient, the infection. So it's, we're kind of at a point in this case. HAI, Pseudomonas, and ICUs are sink drains to blame. Answer is definitely there. It's definitely an issue. I mean, you also have, we're not here to talk about water coming out of the faucet, but you've got the source of the water as well that you need to address. But the drains are definitely becoming, more and more of an issue. There was a paper that showed, they removed all the sinks. It was a study out of the Netherlands, and they just cratered their HAI rate, did a great job. But, at least where John and I run across U.S. hospitals, hospitals are not in a position to just pull all the sinks out of their units. So, okay, what do we do? Like, how do we really address this? We think of drains, we're thinking gram-negatives, but also, C. auris found in biofilms, and also recovered in sink drains. There was a paper that showed over 20%. The C. auris is, it's a growing, it seems like when it comes really hard. So I don't think really anyone's looking. They're not thinking, when they think about C. auris, high touch surfaces and a bunch of other, quick actions. But, it's just another area where if you're addressing the drains, you're going to be, impacting. But the other point on this one is that C. auris does live in biofilms, and they're actually shown one of the main reasons C. auris is really becoming a bigger and bigger problem is that they thrive and live in a biofilm. So in terms of, John's going to get more into specifics, but there's different chemical disinfection methods. If you ask 50 hospitals that have had drain issues or try to address them, what they do, Pretty much all of them have done some sort of chemical. They may pour bleach down the drain. Peracetic acid, there's a peracetic acid foaming chemical on the market. And then the other one would be NADC tablets that create HOCl. They have a biofilm claim. So John will get into the specifics. One of the issues with chemical disinfection, if this is the pipe, and if you're just pouring this chemical down the drain, you're really only getting from the surface area. I mean, that chemical is just going down you're only covering a small cross section of that pipe. What John's going to get into is using foaming agents to get the entire surface area, and then also instead of that liquid just pouring down the drain, it's actually staying with the pipe. And I know there was a session at the APIC meeting a couple weeks ago, and San Antonio and the CDC was talking about using foamers with chemical disinfection. So I'd say this is what most hospitals are doing in terms of if they have an issue. One thing just to be careful is there is, under the Clean Water Drinking Act, you're not supposed to pour anything under 5 pH down the drain. So, check your SDS sheets if you're using a peracetic or a peroxide that it's less than 5 pH. A lot of hospitals, it's labeled, it's got the EPA label, but when you look at the pH of the product, you don't want that stuff ending up in the creek next to the hospital. There's also some new novel products that are coming to market, trying to, instead of from a chemical view, try to hit it from a mechanical, try to not allow that biofilm to come up into the P-trap and into the drain. It's easier said than done. There's been a few of them out. There's also like full sinks, these waterless sinks and other measures. I think the key point is, how can you do this that's affordable, that's relatively easy to install. Facilities would have to do this, and if you could do that, maybe between that and a chemical might be a good approach. This specific device had some pretty interesting data showing some nice drop off and some pretty steady numbers in terms of, again, a physical barrier that pulls, that doesn't allow the biofilm to get into the P-trap. Switching gears a little bit to toilets, and then I'll let John kind of dig into some of the different methods and solution. I mean, I would say opposite of drains, really up until recently, I was at APIC a couple weeks ago talking to infection preventionists, and you start asking about toilets and what products they use, and is it a big concern? And it just has not been on the radar at all. Like you see papers and posters about drains being problematic. I would say just in the last couple of years, there's been more data showing, for example, C. diff recovered from air when you flush the toilet. So similar to drains, you've got the plume effect where when you pour with the drain, when you pour the water into the sink, you get a small plume. With toilets, obviously, it's even greater. So you can get a pretty dramatic plume effect. And if you think of all the measures we do for C. diff, I mean, hospital might spend millions of dollars for a UV robot system to make sure the bathrooms and all the the surfaces are cleaned and disinfected. But think about where an entire bathroom, if you do everything right, you use a sporicidal, but you're not using a sporicidal in the toilet bowl, which is where I hate to say too many C. diff patients spend, or many patients, the C. diff patients spend too much time on the toilet. But when you flush that toilet at the very end of the cycle, you've got air, you've got C. diff recovered in the air for up to 90 minutes. So the entire bathroom is clean, disinfectant. The EVS staff leaves, and then what happens to all those aerosols, C. diff? They completely contaminate the entire bathroom. So that's up to 90 minutes. So that's why we're digging into the toilets in terms of what products you're using, but even before then, there are a number of different studies showing, contaminated toilets are a silent threat. I'd say a growing threat. They live in biofilm, so tying everything back to the biofilm. It's a wet environment. Most of the infection preventionists we talked to, they kind of left this up to the EVS group. You start asking them, what are your protocols? Are you using a sporicidal? What do you do in this area? And I've yet to, I mean, it's just been one of those topics. They leave that up to EVS. What I found, and I think what John will speak to as well, I'd say less than half of hospitals are actually using even a labeled disinfectant, and then over 90%, 90, are using off-label or products not labeled appropriately. I know that's a big number, and when infection prevention hears that, their ears perk up. 90%, how is that possible? Most of the products, and John will get into more specific, if you actually read the labels, they're really not designed to be diluted in the water in the toilet bowl. And also a lot of them are not sporicidal. It might say toilet product with bleach, but if you pull the EPA label, it does not have it's not tested for C. diff, not making a claim for C. diff. So that's, I think that's pretty alarming. I would say if you don't take anything else away from this presentation, we go back to your hospital, see what you're using for your terminal cleans for the toilet bowl, not the outside of the toilet, but the toilet bowl, and ask if it's a sporicidal, if it has C. diff. And I would argue most of them do not. Multiple flushes, you still get C. diff. And again, why is that? This paper didn't really go into detail, but it all goes back to the biofilm, right? So that biofilm protects those pathogens. You might flush, use a disinfectant that's not a sporicidal, but not for C. diff. So this really talks about over time, it continues with continual flushing. In terms of biofilm in toilets, they can persist for up to 50 days. So that's a pretty long time. I know C. diff can survive much longer, undisturbed surfaces, but 50 days, you think about all the work you do for your terminal cleans, and you ask yourself, are we addressing C. diff in the toilet? And I would argue, a lot of cases they are not. I thought this was an interesting, when you think of what are the top areas where C. diff is recovered or where it's contaminated. You think of high-touch surfaces, of course, doorknobs and toilet handle, things like that. But actually, the number 2 most contaminated site was the actual toilet. So again, it's an area where they looked at in the bathroom, the alcohol-based sanitizer in the patient's room, and the patient's bathroom was also contaminated with C. diff. So when you start to think about, okay, how do we address this? You have C. diff in the toilet, you flush, you've got a plume. It's a tough. And in this case, in this paper, even though they adopted all these strict isolation measures, the C. diff was still there. One kind of interesting piece when we were looking at all the pathogens, again, you're thinking C. diff, you're thinking bacteria. This one actually looked at norovirus, aerosolized when flushing. So it's norovirus, I know, is becoming something that's more and more used. And this used a surrogate, and this was a lab paper, but it's kind of an interesting area. When you see these pathogens in toilets, probably not the first place you're thinking, but hopefully some of these data will help frame the issue. There's some new research you'll see more and more research on toilet plume. There's been a couple recently, and I understand there's some more. Toilet plumes actually are even on top of just the bacterial with C. diff. In this case, there were 3 studies that showed C. diff had exposure. But also in this case, it was the chemotherapy agents excreted by the patient. Those are very toxic products, and those are actually, you've got a plume there as well. So toilets, we're talking really biofilm and bacteria. But in this case, we're actually looking at the chemotherapy, cytotoxic drugs. And there are more hospitals using a cover to put over the toilet, mainly for the cytotoxic drugs. The ONS, the Oncology Nurse Society, has a new standard where you're supposed to, before you flush, you're supposed to put a cover over the toilet so you don't have these. They call it a it's a cytotoxic or chemo plume is what they call it. But what some hospitals are starting to look at is, in addition to using a chemical disinfection, using some type of cover, not only for the oncology drugs, the chemotherapy drugs, but also the bacteria. So this could be used on a case, use the chemical at the end of the day, or it's thermoclean. This would be a cover that would prevent plume throughout the day. So between 8 to 10 flushes per day. So this is a mechanical solution against different approach, but again, invented by an oncology nurse, mainly focused on the chemo, but hospitals are starting to, you look at all the data linked to toilets and toilet plume, you start to think, okay, maybe this makes sense, for throughout the day. This is what it looks like. It's very simple, goes on top of the toilet. Last slide here. This is not peer reviewed or published. This is anecdotal. In terms of surveying hospitals, traveling the country the last 6 months, talking to hospitals about their toilet protocols, talking to specific infection preventionists, and then talking to EDS. Out of 18 hospitals, only 3 of those were using sporicidal in the toilet bowl, which is, initially I was really surprised, but now it's definitely the exception. And when I say sporicidal, so a C. diff claim on their EPA master label. 90% used off-label. Most of these products are ready-to-use products. They pour them in a bowl and they're completely diluted. So on top of not sporicidal, you're using essentially not a disinfectant. It's so diluted, it's not being used appropriately. So last question is, what product are you using? Does your protocol match your product EPA label? Because what you think, a lot of clinicians, what you think you're using when you actually look at the label doesn't line up with what you think. So that's my last slide. Next speaker here is going to be John here, who's going to start sharing his screen. And we'll do the Q&A at the end. And like I said, feel free to start typing away in the chat box.
Okay, Dan, thank you very much. Great foundation, and I'll follow up a few more details. Also want to thank Michael Diamond and IC Tips team for hosting the event, and we have about 110 people online, so really appreciate everyone taking their time. We will have a Q&A at the end, so feel free to ask any questions. So as Dan had talked about, these pathogens are thriving in drains and sinks. And I was involved quite a few years ago in an outbreak in an NICU unit where several NICU babies tragically died from Pseudomonas. And they actually ripped the sinks out of the wall. The problem went away for a short period of time, but then came back. And it really shows that drains and piping are systemic, and it's something you continuously need to address. Some of the peer-reviewed studies are showing that pathogens can spread very quickly from the drain to the sink and really to the surrounding areas. Some of the initial findings were that the water, as it runs, can splatter bacteria and pathogens, not only from the drain, but throughout the sink and the surrounding areas. And, in this one study that we're showing here, they used, a surrogate to illuminate after one drain was inoculated, what would happen. And it showed that it spread throughout all the drains in that sink. And one of the more astonishing facts is that bacteria can move up the drain pipe about 2.5 centimeters every day. So that's just under 1 inch every single day. So dramatic movement of these pathogens. And as Dan talked about, when you start seeing that black stuff coming out of your sinks, whether at home or in the hospitals, that most likely is biofilm containing harmful pathogens. Again, some of the things that are challenges that are contributing to it are the sinks and faucets. They're just configured poorly where the water is hitting that drain and causing that splashback and recontaminating, your hand hygiene as you're doing it. Aging water systems. I was just at a hospital in the Massachusetts area that same infrastructure when my parents were born there over 80 years ago. So that definitely is contributing to the problem. And the majority of hospitals really are not doing any type of disinfection on an ongoing basis. So, it's really just creating the problem. Infection control and hospital epidemiology is now recommending that you use an EPA-approved disinfectant, and this is key, that's effective against pathogens within biofilm. As Dan talked about, this biofilm is that protective coating that's keeping them safe against many of the disinfectants that we're using today. And you really need to get that EPA-approved product that's going to have effect. Implementing some sort of drain protocol is critical, both to maintain, keep the pathogens at bay because they will grow back. And I'll show you some of the outcome studies that we've done on this. But you have to have a regular schedule to provide, sustainable treatment of your drains and sinks to keep this from coming back and really preventing that transmission of the pathogens. So the case study we did a case study in a hospital system in Massachusetts. The product that we used was the Foamit device. If any of you were at APEC and came to our booth, we had a nice clear visual of this, nice demonstration. And we simply put 2 disinfection tablets in this 1.6 liter foaming device. It simply pumps up, takes about 5 to 10 seconds to put liquid foam down into the pipe. We have a 4-minute contact time for C. diff. And what's critical to understand is that, the product we're talking about here is called the Fender NACDC tablets, and they have surfactants, so it creates a foam. And that foam basically coats all the outsides of the pipe and actually pushes some of the water out of the trap and allows the disinfection and contact time to occur. It will not work on a lot of disinfectants unless they have that surfactant because it won't create the foam. And the foam is the critical piece to get that contact time. So in this study, we did a baseline biological testing, and we were looking at CFU counts, fungal counts, CRE, and Pseudomonas. But we did baseline test. Then we did the device where we foamed the drain pipe and the trap. And then we let the contact time dwell for 4 minutes, and then we retested biologically. So this process was repeated over 6 weeks. We did it once per week for 6 straight weeks. And I'll show you in a second kind of some of the statistics. But what we learned from this is that although we were treating it once a week and we had a dramatic CFU reduction of those harmful pathogens, the biofilm and the pathogens grew back after every week. So this kind of speaks to the fact that we really should be doing this on a daily basis. And, with about 5 to 10 seconds of application time, it's really not going to add a lot of time to the process. So here's the actual CFU counts and the outcome studies. Again, we had 100% decrease of CRE and a 99.7 decrease of Pseudomonas. We tested an ICU unit in this study, and we did all the rooms within that ICU unit. And the numbers you're seeing are all the sinks combined. So CRE was completely eliminated from 100% of the sinks, and Pseudomonas was, again, 99.7 decrease out of all the sinks in that ICU unit. So a dramatic reduction, and really show the dramatic impact of this very simple process. There's, as Dan had talked about, there's a lot of drain disinfection products out there. We study as an organization what is the best in class, and we believe NADCC, both from our perspective and studies and peer-reviewed literature, is that this is the best log reduction product that you can use. And it also is, it's not that low pH and acidic that is really going to damage your piping and drains. So NADCC had just under an 8 log reduction of these harmful pathogens, far greater than parasitic acid or bleach applications. So that was the sink drain study. I'm going to kind of transition this into toilets and kind of talk about some of the outcomes that we did, very similar to the sink and drain study. But as Dan had talked about, sinks or toilets are a problem. And if you look at the toilet plume, you can see the dramatic amount of aerosolization that happens every time you flush the toilet. And, I can tell you that, we are not, as a society, disinfecting toilets. I'm a former housekeeper. The only way you can properly disinfect this is, unless you're using a tablet-based NADCC, is you have to completely purge the water. And we'll talk about that in a minute, but it's just not a practical application. So commercial toilets can, carry these droplets up to 5 feet above the bowl within 8 seconds and can linger, as Dan had talked about, for a long time. And, certainly this contaminates the sink next to the toilet, any of the adjacent grab bars, and really the whole bathroom environment. So some of the peer-reviewed studies that Dan had talked about is, C. diffs remaining over 24 flushes after initial contamination. It's just sitting in biofilm, protected, and it's really not getting mechanically or disinfectant-wise eliminated. And then the aerosolization is a dramatic problem. So these are some things that, as more and more research, there's tons of research out there showing that this is a continuing problem. Now, again, we did a similar study in a Greater Boston acute care hospital system, ICU toilets, and we found that, the study process we did is we looked at the ICU rooms. We actually looked at several discharge rooms that the toilet bowls, the water in the toilet bowl still had the bowl cleaner color in it. That means that the discharge had been cleaned. They had cleaned the toilet. There was actually a strip across the toilet. And we biologically tested those after those discharge. And then we tested a bunch after regular cleaning. We took those biological sampling on all the bowls, then disinfected them with the product, the NADCC product, Defender, same one we were doing with the sinks, and did a second biological sampling following that disinfection dwell time, which is 4 minutes. And we tested again for CFU, Pseudomonas, and CRE CFUs. And all samples for both the sink and the toilet bowl studies were sent to an independent lab in Washington, D.C., Resinover Lab. And the outcomes of this was Pseudomonas, the baseline, again, a lot of these, half the bathrooms we tested were discharge cleaned, and they still had, over 3,000 Pseudomonas CREs present after using a commercial bowl cleaner. And when we used Defender in the second test, we had 100% reduction. In CRE, similar results, we had 100% reduction after using Defender. So pretty dramatic results. And, one of the challenges is that the current process, as I started talking about, and as Dan had alluded to, really does not work. Really the only way that you can properly disinfect a toilet using traditional bowl cleaners is to completely purge the water out of that bowl. You got to take the Johnny mop or the bowl mop, and you got to push the water out. And I can tell you as a housekeeper, you will be wearing the liquid from that toilet on your body. Some of it sprays on your uniform, some of it sprays on your arm, it could get on your face. It's an inevitable fact when you're trying to purge water, some splashes back on you. So most housekeepers, over 90% in what we've surveyed, and it's probably higher than that, do not purge the water out of the toilet bowl. And if you look at the instructions for use, they're not achieving any level of disinfection, and the biological tests prove that that is a fact. They're, Pseudomonas CRE, and I'm sure we didn't test for C. diff in this study, but I'm sure you will find dramatic levels of all of those harmful pathogens after cleaning without purging that toilet. So again, the current process is unsafe for the housekeeper, it's impractical, and really no one is doing it. So the toilet bowl solutions, there's several that we operationalized with disinfection of the toilet bowls. The most easiest is you simply drop a tablet into the toilet. When you start your room cleaning process, you drop the tablet in, you clean the room, then you go back to the toilet after the 4-minute contact time, and then you swab it around, and you let it disinfect while you're cleaning the bathroom, and then flush it down. So it's a very easy process. You can use a 3.3 gram tablet to disinfect, and or a 13.1 gram tablet to get a sporicidal disinfectant. And you don't need to remove the water. There's about 32 ounces of water typically in a toilet. This is the exact amount that we use for contact isolations when we're cleaning the rooms using this product. So once it's dissolved, it's easy to operationalize, clean it, disinfect it, and again, get that sporicidal cleaning. You can operationalize it with a 32-ounce bottle. You have to pour about 6 ounces of liquid in there, or you can purge the water, and get a disinfection claim. But again, 32-ounce bottle with a tablet in it will get you sanitization. And that's really what's going on with most commercial bowl cleaners, although they cannot claim sanitization because they really have to purge the water. They're not designed to do much with that much water in it. For isolation or discharge cleaning, 2 3.3 gram tablets or 1 13.1 will get you that sporicidal level. Some people are using the smaller tablets, the 3.3s. Most people are using the 13.1s for floor disinfection and room disinfection. So again, it's an easier way to operationalize it, and it assures that high level of disinfection. This is the product that we recommend. This is the Defender product, and this was the first EPA-approved product that was effective against pathogens within biofilm. And that's what we're really trying to achieve, is these pathogens are hiding and sheltering in this biofilm and learning to defeat what you're trying to put against it. And this is a very easy way to operationalize the process, and it's really foolproof in terms of dilution. So very easy way to clean, disinfect, deodorize, and get to those harmful biofilms. So that's our presentation today. Would love to open it up to any questions that people have. Dan, I'll let you facilitate. Dan, you're on mute.
Thanks, John. There was one question that came in on enzymes. There was some enzyme use. I know you've worked a good amount. I think there is, from what I understand, there's a place for enzymes, but it's not a disinfectant, but it can be used, in parallel with a disinfectant.
Yeah, so enzymes are a phenomenal technology and innovation. We work with a company, Realco, out of Belgium. We work with some life science and manufacturing facilities in the medical field, and enzymes are great, but they're not disinfectants. So you always have to, if you're using an enzyme, you got to follow that up with a disinfectant. And one of the challenges in a live environment, such as an ICU, is enzymes typically need about 20 to 30 minutes of dwell time. And they're very good at breaking down the biofilm, and then you can disinfect. But really, to operationalize that in an ICU and taking that sink out of service for 30 35 minutes so you can enzyme and disinfect is really not practical. But again, in a lot of instances, enzymes are a great innovation. They just need to be combined with disinfectant and operationalized effectively.
Perfect. I had a question. I believe it's regarding toilets. It doesn't say. How do you manage the brush? How often? With what do you disinfect the brush with? I understand they would just use their existing protocols, but I didn't know.
I think what they're referring to is the toilet brush. It is, I tell you, this is a gap that in the industry that we have a challenge with. A lot of facilities are using a single use or dedicated to that one toilet and discarding after discharge. So it's only dedicated to that one toilet is really the only practical way to manage around it. If you're taking a toilet brush from room to room to room, you're really creating cross-contamination, even though you're submerging it in a sporicidal disinfectant. At least using the tablets, you're sporicidally disinfecting that toilet brush every time.
Yep. There was a question. I'm not super experienced. I have a lot of experience in sterile processing, but they're asking comment on sterile processing. CSR department drains. I know they do they soak reprocessed devices. I mean, based on what I've seen, there hasn't been a lot of. I mean, it's similar to an ICU drain. There hasn't been a lot of focus on the specific drain. So I would assume you've got, you would do the same treatment. You'd want to use a foaming agent. I don't know if you've come across these, John, or not. You might actually have more chemical going through there. So it would seem like it would maybe be less, but you also have a lot of organic material. So you would just assume there's a lot of biofilm in there.
Yeah, we've tested these units before. They have similar challenges. Certainly an ICU is going to have a more organic material putting down those sinks. But look at these units have the same problems. These drains have been existent for 10, 20, 50 years or more. They are growing biofilm and they're growing harmful pathogens. So when we've tested them, we've found very similar readings and the same harmful pathogens. Be happy to go out to any hospital and help with you on that.
Okay. There was a question, what is the time frame when you tested for biofilm after Defender use? I believe that was weekly. Was that?
Yeah, so when we did, there was two different tests. So the sink study in the ICUs was conducted over 6 weeks. Every week for 6 weeks, we would baseline test the sink drain, and then we would treat it with the Defender and the foaming device. We would wait 4 minutes, and then we would retest. That's where we got the dramatic reductions. The toilets, we simply biologically tested it. We used the Defender in the toilet bowl, waited 4 minutes, then retested, and that was the time frame for both of those processes.
Okay. John, I think you'll appreciate this question. You only speak about sink and drain toilets, but a large percentage of bacteria comes from floor drains. Will you do a presentation on this in the future? I mean, from my view, you're the same. I mean, it's a similar. I mean, you're still dealing with the same problem, biofilm and drains. But I didn't know if you have.
Yeah, I mean, I've had a lot. This is a big challenge. So floor drains are notoriously a challenge in a multitude of ways. We've worked with facilities that have had major fly challenges with drains, floor drains. And in that case, we did use an enzyme because there was more time that we had that we could treat that drain with an enzyme. We waited 30 minutes. Then we applied the Defender, and we were completely eradicated the fly challenge. The other part of floor drains is all sinks have a P-trap, a kind of what I call a U-turn that holds water. Well, if a floor drain
Yep.
dries up, they're going to be susceptible to smells and sewer flies that can come out. So pouring down some Defender once a week keeps that trap moisture filled and the way it was designed to be used. But this can be applied to floor drains very easily for this purpose.
Going back to the toilet brushes, because we asked maybe a follow-up. It says toilet brushes disseminate aerosols for some distance. Is this a good idea in high-risk areas? But I don't know. Toilets, those would usually not be in the, like in an ICU. Have any data to determine this? I think toilet brushes would be in a patient's bathroom, correct? But they wouldn't be like in the actual ICU. So I don't know. They might be crossing between drains and toilets on that question. I don't know your thoughts on that.
Yeah, I mean, look, it's a gap right now. The best thing to do is use it and get rid of it in these high risk areas. There's, or use it for that one patient, and then when you're using Defender, it's going to disinfect it. But like anything, organisms can grow back. It can disinfect it at an extremely high log because of the concentration. So you're minimizing the risk. But the ultimate best practice would be single use. There's just not a practical application or many in the industry right now. I would use Defender to disinfect it every time after use.
Yep. There's a question it's a good question. It said, did you test 1 day after application in the drain study? It seems important given the 2.5 centimeter per day progression of biofilm in drains. I think you did a week, and it's we've seen, I think, more and more studies that show, depending on, I mean, the biggest question to me is if you treat the drain with the foam protocol over a period of time, even if you do it on a weekly basis, or if you do it maybe twice a week over time, can you get to a point where you can get to a weekly because it is growing back? And I don't, that's the challenge.
Yeah, I mean, the reason why we picked 1 week, quite frankly, was this was, we had to pick a time period. There was a study done out of a hospital in the Boston area where CRE was an outbreak challenge. And so we modeled that with this hospital system to try to address the problem. So we cut in half the time and went to 1 week. We certainly are going to do this again with 1 day increments because it grew back pretty rapidly. I would recommend once a day. It's an easy application process, so your housekeepers can operationalize it. I was able to use one of those containers in all the ICU. And again, it takes, if any of you were at the APEC conference in our demo booth, you saw that we were able to treat the drain in about 5 seconds. So this is something that we will follow up and continue to research. But it was a pretty comprehensive study over 6 weeks and a lot of samples, a lot of money to put this forward, but we will go to a daily process in the very near future and republish.
Yep. There's a question, how well do the tablets work with building water supplemental disinfection like monochloramines, copper, silver, chlorine dioxide? I come from that world of water treatment, so it's an interesting question for me. I would say, the reason you use them is that any of those systems work well, but at the end of the line of those, which is where a sink is, if you've got that biofilm, it's going to be challenged. So really what we're talking about is the faucet and then where the P-trap comes down. In terms of interaction with those supplemental disinfection? I mean, it's a fair question and probably one to look at, but at the same time, I believe the residuals of those when they get to the end of the line are so eaten up by the pathogens and the biofilm. It's a good question, but I'm not sure. Not sure how we'll have an answer on that one. Bunch of great questions. Would NADC products be available for the internal components of ventilators? That question is a great question, but I think the ventilator would have. I would say it could be, but the ventilator company would have to do the testing, and I believe would have to that would have to be included on their FDA label. It is being used on certain devices in hospitals, but it's can't just be used as a surface. Any disinfectant is labeled as non-porous, hard surface. When you get into medical devices, then it's really up to that company to do testing, and then it would be included in their label. There's a question: what is the cleaning disinfection protocol for the splash blocker, which is the toilet cover? Does a wipe, bleach remove the chemical contaminants? Yes, that's what I believe what they use. They'll use a bleach wipe or whatever they use to wipe the toilet down. John, if there's a bunch of them here, we'll take. We got 5 minutes. Can we use bleach to disinfect the restroom? Bleach is used widely. I'd say it's the #1 product being used for thermal cleaning. I'm a little biased because I've been involved with products that compete against bleach. I think the only question would be, and it's considered the gold standard, but at the same time, what we're talking about today is within the toilet bowl. So if you use a bleach wipe on the outside of the toilet, I mean, that's what a lot of hospitals use, and those are typically sporicidal, so they kill C. diff. What really we're challenging here today is within the toilet bowl. They might use a bleach wipe on the outside of the toilet, but they might use a toilet bowl disinfectant with bleach for the bowl. And if you read and you think it's bleach, okay, bleach kills C. diff, right? Well, most bleach products do, but if they actually look at that product, it's not sporicidal. It doesn't kill C. diff. So those are the.
And one of the challenges. Look at bleach has been a widely used product for many years, but we've done a lot of research, and it's extremely caustic chemical. It's very caustic on your people, on your surfaces. It destroys a lot of things. And, depending on your brand, it's not effective against pathogens and biofilm. It doesn't have that claim. So you really need to understand that we're trying to get to the pathogens and biofilm. We're trying to keep our housekeepers and our workers and our equipment safe. If you go to Europe, they don't use bleach anymore in a lot of the facilities. It's basically been ruled out. I did a lot of work in the UK, and they got rid of bleach because of health and safety alone. And their C. diff rate was twice the US at the time. Now it's half of it. So look at NADCC is a great product. It can be used in any environment. And that's what a lot of the European countries moved to a long time ago. One of the fastest growing disinfectants. You can use it on the floor, that we know is a key contributor. And it's effective against biofilm. And that's what you always got to ask for, is what products are effective against biofilm or pathogens within biofilm. But I think we're just about right at the end of our time. I know I got another presentation at 1. We will try to follow up. We'll kind of get all the questions and kind of try to do some follow up.
We'll post all the questions, and we'll include some answers, some specifics. We'll post those on the TIPS website, so you'll get an email. Thank you for joining. It'll link to TIPS. It'll probably be early next week. And then we'll have John go through the questions. We'll answer those. And if there's one that's we're not sure, we'll provide some references, and then we'll go from there. Thanks a lot, John. It was great discussion. Thanks everyone for joining, and keep your eyes out for the next TIPS masterclass.
Thank you.